after Fibonacci 10, so on and so forth. And until we meet the base case like Fibonacci 1 and Fibonacci 0, and then we can like just directly return those base case, right? And those method will be like popped from the stack first. So it's like a first in, first out. So this is the sorry, not first in, first out. It should be last in, first out. Sorry for my mistake. So that what I'm trying to say is that the newly atom that added into the stack should be the first to be popped out. So it's like a last in, first out. Sorry for the mistake. Let me note here. Last in, first out. So the last one get put into the stack will be the Fibo 0 and Fibo 1, right? So they will be popped out first. So it called a stack last in, first out. And after you pop out this two, you got the result of this two, and then you can use it to compute Fibo 2, right? And then after this, after you compute Fibo 2, you pop it out, and so on and so forth until you like finally pop the Fibonacci 10. So this is the rules that happens in the stack. So also with this rule, like how we manage the master frame, this is also the reason we call it the stack. And also within the master frame, we store all the like method parameters and all the local variables inside the frame. So this part is for the stack, and what is stored in the heap. So other like the class class metadata, those class field data member, and all the like the master execution code, those things will be stored in the heap. So sometimes some articles will call like a place called method area, if I recall correctly. And they might say that this place is separate from the heap, but actually some article will just group them together, just say those things are all belongs to heap. So maybe let's just keep this simple. So those things will be stored in the heap, like the metadata, and those data won't change based on the input. So those kind of constant thing will be stored in the heap, and but those local variables will be stored in the stack. And so also when talking about this heap, you have to also mention the structure, like how JVM manage the heap. So because the stack just store the local variable, so maybe it does not need that much space. So you do not need to have like a special architecture to manage it. But for the heap, because the heap store all those like the metadata, so it needs a like very large space, like all your objects, all your real objects and the class metadata, those things will be stored in the heap, and for the like the local variables reference will be stored in the stack. So in the stack, we just store the reference, but the actual object will be stored in the heap. So the heap will need like a very large space to store all the things. So then we will design a special architecture to manage our heap. Like we need to make our garbage collection to be efficient, to be efficiently executed in this space, in this heap area. So what JVM do is JVM will separate our heap area into different regions, different areas. and based on the generation of the areas, different garbage collection algorithm will happen, and also the intervals for those garbage collection algorithms will different. So like in the young generation, because there is a theorem that um, prove that all the young objects they won't survive after like several garbage collections. Though 90% of the object will be garbage collect in the first few garbage collection periods. So there will be like more frequent garbage collection intervals, like the frequency in the young generation. But for the old generation, because it is like already been promoted into the old generation, so there's less likely they will be garbage collected. So the garbage collection will happen less frequently in the old generation. And by like manage them into those different areas, we can make our garbage collection more efficiently. So let's have some detailed examples for what I said previously, like the old generation and young generation. So first, I said that a heap manage itself uh, by divided into several areas, right? So first is the young area that we called it young generation. So this part of the heap memory will be also will be divided into several parts called Eden area. So the Eden area will be the youngest part in the heap memory block. So even in the young generation, the Eden area is the youngest. Like every time you created an object, this object will be first created in the Eden area. And after its survival several GC periods, it will be promoted into the survivor area. And but this survivor area will be um, we will have two survivor area. So one we call it survivor, sorry for the typo, survivor 0, and another called survivor 1. But these two survivor areas, they are equivalents. So what equivalence means, they are basically the same. So the reason to keep them is just for data compaction. So because the young generation just have a small piece of memory. So when we have like garbage collect part of the objects, there will be some fragment in the memory area, right? So because it's just a small piece of memory block, what we do to compact this memory block to reduce those fragments, we just copy paste all the object from the S0 into S1, and then we can compact the objects. But uh, like their generations are just the same. We just use them to like for the compaction reason to move all the objects from like after several GC periods, we just compact the data, like copy paste all the data from S0 into S1. And when S1, sorry, maybe when S1 after some GC period, it also has many fragment inside it. So we just copy paste the data from S1 to S0. So, but their generation is the same. Like Eden area is younger than the survivor, and so but after the objects survived in the survivor area for several like um certain periods of certain times of garbage collection, it will be further promoted into the old generation. So this old generation will basically be a very large chunks of memory. So we do not have like things like old one, old 0, and old 1 and to like copy paste all the data from it. So we will just after some like several times of garbage collection, if there is some fragment, we just compact them, just to move the object and compact them in the same area, so we won't have the mechanism happens at survival area. So this is called old generation. And also, um, maybe after Java 8 or in before Java 8 or in Java 7, I cannot remember it very clearly, that there is also a area called permanent, sorry, permanent. I forgot how to spell it. So there is also a area called permanent area. So those area will be store all the class definition and method execution code. But um, those I believe this area has been removed, has been deprecated after Java 8, and now they are using I now the place they used to. Okay, cool. Permanent. Sorry. Oh, I typed the E into A. So, but I believe after Java 8, they use like another terminology to call this place, but like they deprecate the permanent generation. They just use the meta space to store all the class definition and method execution code, I believe. But what most important is these two parts, because the like those class definition and the method execution code, we won't like have some, we do not need to care about the garbage collection on those. We just, those are just the metadata. But for the like the alive objects, yeah, sure. But uh, I can give you the record permission, but you better to use your like own recording tools to record this, because the permission setting is for one time. So I don't want to every meeting I give the permission to. Yeah, I now give you the permission. So um, but for this, like the young generation and old generation, they are used to
Recording in
store
progress.
they're used to store the objects, right? The objects needs to be frequently like garbage collection. So these two generation, the mechanism, like the garbage collection happens in them. You have to be like more focused on this two generation. So, two part of heap memory block. So as I said before, like the garbage collection will happen in this two area, right? So the garbage collection flow will be like this. So whenever you created an object, first, once the object is created, it will be resident in the Eden area first. So first into the Eden area, and after its survival for several GC periods, it will be promoted into the survivor 0 or survivor 1. So only one of the survivor area will be activate at the same time. Like when S0 is working, S1 will not working. So only when we like after several times we want to compact the data, we will like move all the copy paste all the data from 0 to 1, and then this time S1 will start working and S0 will be like in idle. What does GC period means? What I mentioned GC period is just a one GC collection. So like the GC won't happens like all the time in the background. It just like maybe after several time it collect once for all of your objects. So this is I call the GC period. That you maybe I just changed my term just to call it one GC, one garbage collection. So like after the object survival several garbage collection, it will be promoted into the next area. So the Eden area, the object in the Eden area after it um, after survive after it survive like several garbage collection. Uh, after it survives several garbage collection, it will be promoted into either survivor 0 or survivor 1. And after it uh, continues successfully survived after several GC garbage collection, it will be promoted into the old generation. So this will basically to be the like the flow of our how JVM manage our object. And also there will be like different types in of garbage collection algorithm, and you can set them when you start your program. Like you can provide them as a parameter when you start your program. So one that's also as I mentioned previously that there will be different algorithms running in the different generation, right? Because their heap size is not the same, so we have to use different, and also their frequency is not the same, so we better use different algorithms to running in different generations. So in young generations, there will be some garbage collection algorithm called serial serial garbage collection. So the serial garbage collection means only one thread is using for garbage collection. And also we will have something called parallel parallel GC. So parallel GC, just as the name infers, it will have multiple threads to like mark your object and sweep your objects. And also, we will have something called, um, so this, when you use the parallel GC, it's actually like using the parallel new GC in the young generation, like it will use multiple threads to do garbage collection in the young generation, but it will just use a serial garbage collection algorithm in the old generation. That means when you use parallel GC, it will have multiple threads working, doing garbage collection in the young generation, but only one thread doing garbage collection in the old generation. And we can also like set like parallel new GC. So the parallel new GC, the difference between parallel GC and parallel new GC is that parallel new GC will have a better support for working with an algorithm happens in old generation called compare mark and concurrent mark and sweep. But parallel GC would not, because parallel GC just like designed to work maybe with the serial garbage collection algorithm in the old generation, so it will not that perfect to work with the CMS that we call concurrent mark and sweep. So in the old generation, there will be some garbage collection algorithm called parallel OGC. So as I mentioned previously, if you just like provide the parameters as parallel GC, then in the old generation, you just use single thread to manage the garbage collection, right? But with you setting the parameters at as parallel OGC, then in the old generation, you will also use multiple threads to handle the garbage collection. So using multiple threads to do the garbage collection will be like provide some favor to the big projects, because for a big project, maybe you will just using a single thread to do to manage the garbage collection, maybe it will be not sufficient. And also as I mentioned previously, one thing called CMS, that is the concurrent um, mark and sweep. So why we call it concurrent? That is because all of the other algorithm I introduced previously, they will, when they're doing the garbage collection, they will freeze your program. That means they won't run concurrently with your real application. So they will call one construction instruction called stop the world. So just as the name infers, it just to stop the world of your program. So it will freeze the state of your application and start to mark all the objects that are alive or that are like on um, are already like unused, and then it will sweep all the unused object in your heap memory area. So but for the concurrent mark and sweep, things are a little different. Although the concurrent part of the procedure of concurrent mark and sweep, they will still need to stop the world and doing some mark or sweep, but they will provide some procedure that can running concurrently with your uh, application. That is, your application can keep running while the concurrent mark and sweep also running in the background. So um, I can give a like a brief introduction for the stages in the concurrent mark and sweep. Concurrent mark and sweep. So um, the first step is called initial mark. So this part of the CMS, it it needs to stop the world instruction. That means you have to stop your application and only run this garbage collection step. And then and then you will, in the initial mark, you will mark most of the objects that are like whether they are alive or they are unused. And the second step called concurrent mark. So as you have already marked most part of your objects, then you can like resume your application to start running and then mark those objects either they are in use or not, or like unused concurrently with while your application is running. And after this concurrent mark step, you will call one thing called final mark. Because, and this is also need to stop the world, that needs to stop your application. So why we still need this? Because when you concurrently running with the application, maybe like because it's like you are keep creating new objects and also like keep on using some objects, then there will be some like omit object. You need to use a final mark to check it and make sure that all the objects are like marked correctly as used or unused. So, and after this final mark, you will do another thing called concurrent sweep. So this step is you will resume your application into running and then concurrently while your application is running, you will sweep all the unused objects. So why we will need this concurrent mark and sweep algorithm compared to like other algorithm need to stop the world? So actually the advantage is quite obvious that if your program requires like the less downtime, like if you just use those algorithm, then your program has to stop and then waits the garbage collection finish and then resume running. So if your algorithm, not algorithm, if your program requires that you have less downtime, like you must for the most of the time you need to keep your program running, then you better choose the concurrent mark and sweep to like, but this algorithm will absolutely slow down your program's performance because you know you have to run in your application along with this concurrent markings. Sometimes with concurrently running this garbage collection algorithm, it will like occupy part of your CPU resources. So with this algorithm, it will sometimes slow down your program a little bit, but but this is like a trade-off. Like if you prefer your program to keep running most of the time, then you have to make some sacrifice, like some trade-off. But it's a choice for you. Like to when you run your program, you can set those parameters to choose different garbage collection algorithm to use based on your like program requirement. And oh, one thing I need to mention about is also that one thing called GC root. So the garbage collection root. So what is the GC root is this is function just as a root, and you will search from this root to reach all the reachable objects and mark them as like alive. So as I mentioned previously, that for the initial mark, you have to mark all the objects in order to in the future you want to sweep them, right? So you so how do we find those objects that whether they are in used, they are alive, or they are already like unused? We are using the GC root as a start point to start searching for those objects. So the GC root, you might use like the class loader as the GC root, like a start point, or just use the class as the start point. So it's just like you will start from the class loader and find that what class in the class loader, and maybe you will further check which data member inside the class, and just like searching from the root and go layer by layer to search all the objects that has still in use that have a connection to the previous layer. And if there is no connection, that no one is using this object, then you can mark it as unused, and then later you can sweep them. So this is the usage of GC root. It just um, work as a like a start point for mark. So you will start from the GC root to try to mark all your objects. And also you can even use like something called monitor, but this thing will introduce what is a monitor in the synchronized part. So monitor actually just like a log. So so I can give you a brief introduction here. Like for the synchronize, you want to make sure that when you synchronize a method, that means you want to make this method to be critical, right? You want to make sure that at one time only one thread can get into this method. So how you do that? You just like provide a log, the same as provide a monitor, and only the thread who can acquire the monitor, then it can execute your method. So, and also because there is only one monitor existed here, so that makes sure that at the same time only one thread can acquire this monitor and running your method, right? So, and also this means we can also use the monitor as a start point to like further try to traverse to see what object is in use or not. But those are just some concept. Knowing them is good, but I never met interviewer ask about GC root, but it's good to know. And also, oh, so and also besides that, like categories those garbage, and also there is a like a way to categorize those different types of garbage collections algorithms. So those happens in the young generation. Those garbage collection algorithm happens in the young generation. We will call it minor GC, and so those things will be minor GC, like the parallel GC and parallel new GC. And for the like happened in young generation. And what happened in the old generation, we will call it um, major GC. So those like compare concurrent mark and sweep and parallel OGC, we will call it like we will call it a major GC. And some algorithm will happen both in the young generation and old generation, then we can call it a full GC. So the serial GC, there is no material that's saying that serial GC is full GC, but actually like the serial GC, there is serial GC in the young generation, and also there will be serial GC in the old generation, but I'm not sure whether they are the same algorithm, but or they just have the same name. But I can make sure that one algorithm will be full GC, that is called the G1 algorithm. But G1 algorithm will happen both in the young generation and the old generation, but G1 algorithm will manage your heap memory area a little bit different compared to this manner. The G1 algorithm will oh sorry, the G1 algorithm will further split all your heap memory into small chunks. So it will and they will have like equal size, but it will be splitted into like many um, small chunk of memory. And each chunk of memory, they can either be like Eden area or be survivor's area, or they can be like old generation. They can be either one of it. And what G1 do is it will so because G1 have separate those memory into small chunk piece of memory, right? So it can choose like um, several slot to do the garbage collection. Compared to the other algorithm, it have to be garbage collect on the whole area. So it will be a little bit slower. And but for our G1 algorithm, it can just select partial of the slots, so it will have a better performance. And also, because those areas are managed in a fashion that's in a small chunk of memory block. So what we do is when we trying to after several GC happens, there's some fragment in the in this mm, bucket, let's say, and it will just like move all the move all the object, copy paste out object into another unused, like maybe some of the area has already been marked as either survivor or old generation, but there will be also some unused block. Then it will just move all the things into the unused block. And also something is similar that like suppose your objects has survived several garbage collection in the Eden area, then after you promoted it, it will be moved to a new area, and then it will be marked maybe as a survivor area. So it will be more flexible when you use the G1 algorithm. But the idea is still the same. Like the object, when it created, it will be first resident in the Eden area, and after several GC garbage collections, it will be promoted into survivor area, and so on and so forth, promoted into the old generation. So this idea is still the same, but just the fashion it managed the memory block changed. It further divided those memory into small blocks. So this is called G1 algorithm, and G1 algorithm is a full GC. So it managed both the young generation, like a survivor and Eden area, and also it managed the old generation. So it will be a it will be a full GC. So yeah, I think. Oh, one thing is that, does anyone know in Java, can we force GC? Like, can we force garbage collection running? So anyone know the answer? Like, can we force GC? Like, we ask GC to run. Can we do that? Any answer? No, actually no. So actually we cannot force GC to run. So garbage collection can just be managed by our like JVM. But sometimes it might confuse you that you might seen this statement like system.gc, right? But actually, this statement it just provide a suggestion to your JVM. You cannot force your um, you cannot force your JVM to say, hey, please run GC. Use this when you run this code, you cannot like force your JVM to run a garbage collection. You can just provide a suggestion to your um, Java JVM. So maybe the JVM will follow your suggestion, but maybe it will have its own schedule. It won't follow your suggestion. So yeah, but if you write a code to test the system.gc, I think most of the case you will see that JVM follows your suggestion. Maybe let me try to test it. I, so also we can, in this case, we can like maybe we can override the finally method in order to test our system.gc method. So the finally, not finally, the finalize method. So there is a already deprecated method called finalize for every object type objects. So, but you have to override it. The finalize method, what does this finalize method work is it will execute this method when the object being garbage collection. So before this object being removed from the JVM, it will execute the finalize method. But because this will like give extra load to your garbage collection algorithm, like it will slow down your garbage collection performance. So this method has already been deprecated. That's not suggest Java not suggest you to use this method, but we can use it as a test demo. So here we can override. Maybe let me recall that method. I cannot remember the like the method signature correctly, but let's see. Override deprecate method. Yeah, I think I got the correct method signature because I seldom use this finalize method. It's already been duplicated. You see, it's already been deprecated. You see, there's a line on the method that means you're not suggest to use it. But just for a demo, let's use it to say I am out. So and then you can write maybe a method to try to test it. So now let's just create it and test 10 objects, but we do not provide any reference variable to it. So that means when we create it, there will be no link to the GC root. So it will be marked just as unused. So let me do it. And here we will call the system.gc. Let's run it. So when GC happens, like garbage collect this test 10 algorithm, before it removes, it will invoke this method, right? So you see, when it got removed, it called I am out. But if you comment out this is just a suggestion, not mandatory. So This is just a suggestion. But most of the time, I think the JVM will follow your suggestion. So now I comment out this, then that means we just let the JVM to manage the garbage collection as it's wished. So you see, we cannot see the output. So that means at uh at least at this moment, the garbage collection not happen. So this object not get removed. But you see, we can run it again. Nothing happened. But if we come out this, we give the suggestion to the JVM and run it again. We can see the, the object being removed. But it's not a mandatory. We cannot force it. We just this is just a suggestion. So yeah, I think this should be all that I want to talk about for garbage collection and Java memory model. So yep, and so far, any questions related to this part? If no questions, then let's take maybe 10 minutes break and let's meet again at 10:58.